Okay, I'd like to finish up section 2.3 here. So we're on problem 39. We just did problem 38. And on problem 39, I want us to write a symbolic description of the area shown in the Venn diagram. We used letters A, B, the intersection sign, the union sign, the subtraction sign, and the complement sign as is needed. Okay, so when I look at this here, I see that we're talking about everything that's not an A and B. Okay, so A minus B, that's something that we've already done. A minus B is the complete opposite of what I have as it is shaded here. So one answer that you could give is to say A minus B, the complement of that. Okay, everything in A and not in B, the complement of that. Okay, everything in A, everything not in A means everything outside of circle A, or B. Okay, means shade all of B, and of course I got A complement already shaded there, so this would be another answer that you could give. Okay, either one of these answers, and by the way, there's other ones that you could give, are acceptable. Okay. Problem 40, write a symbolic description of the shaded area as it's shown in the Venn diagram. Use the symbols A, B, C, the intersection sign, the union sign, the subtraction sign, the complement sign as is necessary. Okay, so by the way, for this stuff, like it helps to say in words what the shaded area is. Okay, so we're talking about everything in A and not in B or C. Okay, B or C. So everything in A and means intersection, not in B or C. Okay, that'd be what I've got shaded there. Okay, now I can use De Morgan's law. Okay, De Morgan's law says that if I distribute this complement sign, that I got to switch the union sign to make it an intersection sign. So everything in A and not in B and B complement and C complement. Okay, so that's saying the same thing as I just said. A minus B minus C. Okay, so take everything in A, subtract everything in B, subtract everything in C. You'll have what's left over there. That'd be another answer that you could give. A minus B or C. Okay, so B or C is where I shade both the circles. Okay, everything in A and not in B or C. Okay, so any one of these answers are acceptable to give. They all represent this shaded region here. Problem 41, write a symbolic description of the shaded area as is shown in the Venn diagram. Use the symbols A, B, C, the union sign, the intersection sign, the subtraction sign, and the complement sign as necessary. Okay, so again, what I think helps is to say, in English, what is the region that we're talking about? Okay, so we're talking about everything in B or C, but not in A. Okay, well that'd be B or C, B union C, but not in A. Okay, so I'm getting rid of A. Okay, B union C and not in A. Okay, so A complement means where would you have shaded twice? Okay, well if I get everything in B or C shaded and everything outside of circle A shaded, where would I have shaded twice would be what I have circled here, or in dark. So another answer that you could give is to say B minus A. Okay, that'd be this region here. Union means I'm going to add in more to what I've already got. C minus A. Okay, so C minus A would be this region here. Union means I'm combining those two as one. Okay, so any one of these three results is a solution to the problem there. A definition, the Cartesian product, or sometimes we say cross product of sets A and B, which is denoted by A cross B, is the set of ordered pairs AB, where A is an element from capital A and B is an element from capital B. Okay, so as an example, suppose we have problem 42 here. Consider the sets A, which is the set containing 2, 6, and 8, and B, which is the set containing 1 and 5. Okay, part A, find A cross B. So A cross B is a set of ordered pairs. Any element coming from the first set needs to be listed first. Any element coming from the second set needs to be listed second. Okay, now I'm using ordered pairs, so order is important. Okay, so like I see 2 and A, and why don't I list everything that's, with 2 leading off there, so 2, 1, and 2, 5. Okay, and then move on to the next element, that's an A, so 6, 1, 6, 5, and then 8, 1, and 8, 5. Now, the order pair 2, 1 is different from the order pair 1, 2. Okay, if I were to plot those on a graph, I'd be located at 2 different spots, okay, because order is important. Part B, find B cross A. Okay, so anything in B needs to be listed first, anything in A needs to be listed second. Okay, so 1 is in B. When I list everything in, with 1 leading off, so there's 1, 2, 1, 6, and 1, 8. Okay, and then if 5 is leading off, I got 5, 2, 5, 6, and 5, 8. Okay, so close the set. By the way, one mistake that I sometimes see, by the way, a couple mistakes, but one that I sometimes see is that a student, instead of writing 6 elements, they write 6 sets. Don't do that. We only have 1 set. Okay, so I only want to be using these set brackets 1 time. Okay, remember with if I write 6 sets, order doesn't matter. Okay, so 2, 1, that's the same as 1, 2. 2, 5, that's the same as 5, 2. It's not going to matter. Well, it does matter. Okay, with Cartesian product, it does matter. Another thing that I sometimes see is that a student forgets to use commas. Okay, when they should have commas. So that's a problem because what it looks like is that you've got a set with only 1 element in it. No, we don't. We have a set with 6 elements in it. Okay, so the comma separates the 1 element from the other element. So there's a couple of things about Cartesian product that need to be there. Part C, if I want us to find A cross A, okay, so I got a set of ordered pairs, and I'm using only A. So anything in A needs to be listed first, anything in A needs to be listed second. Okay, so 2, 2, and when I start off with the listing everything where 2 is at the beginning there, so 2, 2, 2, 6, 2, 8, and then 6, 2, 6, 6, and 6, 8, and then 8, 2, 8, 6, and 8, 8 would be the answer there. Again, 1 set, 1 set. By the way here, notice that A cross B is not the same as B cross A. Those are 2 totally different things. Okay, so order matters when you're listing things in this set. So anything in, if it's A cross B, anything in A needs to be listed first, anything in B needs to be listed second. Problem 43 says that if the cardinality of A is S and the cardinality of B is T, then the cardinality of A cross B is S times T. Okay, so cross product means multiply. So like if the cardinality of A cross B is 3 times 2, let's say if you got 3 things in A and 2 things in B, okay, 3 times 2 is 6, okay? From problem 42A, so there should be, and B, so there should be 6 elements listed here. Yeah, that's true. There should be 6 elements listed here, okay? The cardinality of A cross A, well, I got 3 things in A, okay? Times 3 would be 9, 3 times 3. So I should have 9 ordered pairs listed, okay, if I were to find the cardinality of A cross A. For problem 43, I want us to find the cardinality of C cross C. If C is the set given there, Now, remember with sets, you can list an element as many times as you want. You're only going to count that as one that is different from the others. Okay, so I have a set with 6 things in it, not 8. Okay, since M is listed twice and A is listed twice, I'm only going to count that as 1. Okay, one that is different from the others. Okay, so I've got a set with 6 items here. Okay, so 6 times 6 is 36. So if I were to list the ordered pairs that would be in C cross C, there should be 36 ordered pairs. Okay. We're now done with section 2.3, so the homework is on page 72. Be sure to look at the problems there in section 2.3 for me.